Okay, we are going to pick up where we left off yesterday. This is going to be 7 for day 2. And 7-5 day 1. So we'll jump right into an example, a little review from yesterday. If we have a vector with direction -2, -5, so that's our horizontal and our vertical components, can you find the magnitude and direction? So the two components that are making up our vector, left 2, down 5, and head to tail. So the vector we are looking at is in the third quadrant, right here. So we want to find the magnitude of it, which is basically just the length. So that's a little Pythagorean theorem. And remember, this is a right triangle here. We don't have to worry about the negatives when we do Pythagorean theorem. So it's just a little leg squared plus leg squared equals that hypotenuse squared. So that's 24 plus 25. We're going to get 29. Square root both sides. So our magnitude of the resultant is square root of 29 as an exact value. Now the direction, remember, the direction comes from due east around clockwise. Well, if I start here from due east, there's 90. If I keep going, counterclockwise I meant, keep going, there's another 90, so I've got a 180. Then all I need to know is what's this angle in this triangle here. And I'll add it on to the 180 that was the first two quadrants. So we're going to do a little SOHCAHTOA. So I'm trying to find this angle, so I'm going to stand here. This is opposite. This is adjacent. That's a good old tangent, TOA. So the tan for my angle X is opposite is the 5. The adjacent is the 2. And you can put the negatives there and they're just going to cancel out, so it doesn't matter. So now to get the angle, I'm just going to go with inverse tan. Remember, if you're trying to find an angle, those are your inverse buttons. So inverse tan of 5/2. Let's see, mode, radian, that's not good. Degree. Inverse tan, 5 divided by 2 is about 68 degrees. Then add that on to the 180. Our direction is about 248 degrees. Okay, that was a review from yesterday. Here's a new one, number 2. Okay, can you find the angle between two given vectors? Angle between. And when we say angle between, they want the smallest angle between. And here's our two vectors given like with the horizontal and vertical components. We got a -2, +5. And then we have a +4, -3. So sketch it and see what we're actually looking for. So -2, then a +5. So left 2, up 5. So the resultant vector there is in the second quadrant. And then our second vector, right 4, down 3. So right 4, down 3. Here's our second vector. So our goal is to find the angle between those two red vectors that I just drew in. And we want the smallest angle between them, because technically you've got this angle that's between them, and you've got the one that's around here. But because I think I did a fairly good job sketching, I think it's going to be the one on this side. So you're looking for the one that's less than 180. So if you think about it, our goal to find that total angle measure, if you chunk it up, well, you got the middle part here. This is 90 degrees. So I would need this angle here, and I would need this angle here. So those are my two angles. I'll call this one X and this one Y. Once I know those two, I'll add them together with the 90. That will give me the total angle in between. So it's just a little simple SOHCAHTOA again to find a couple of angles and then add them together to get that angle in between. So once you've got the picture, it's pretty easy to see what to do. So let's start down here with this triangle. This was a 4 and a -3. And again, I don't care, when I do my SOHCAHTOA stuff, I'm just working with right triangles. I don't care about that negative, because I do just want the little acute angle here. So again, that's going to be opposite and adjacent, so that's a tan. So the tan of X, so opposite is the 3, adjacent is the 4, and then it's inverse tan. So inverse tan, 3 divided by 4, that angle in there is about, I'm just going to go to the nearest whole degree and say 37 degrees. I could say 36.9, but we'll go 37. The other one out here now, remember, I'm going to use my triangle. This side is a -2. This side is a 5. Or I could think about the triangle up here too. That might be a little quicker, save myself a step. Because I know that this is going to be a distance of 2, and the vertical is going to be a distance of 5. So I can use this little triangle out here and go with a tangent also, with opposite being 2 and adjacent being 5. So that means the tan of Y, opposite is the 2, adjacent is the 5. So we will inverse tan that. Inverse tan, 2 divided by 5. I'm getting about 22 degrees. And now to answer the question, the angle between, that's going to be 22 plus a 90 through the first quadrant plus the 37. So 22 plus the 90 plus the 37. 149 degrees. Okay. And I think this might be a new one. Number 3. Before we get to this one, though, I want to review a parallelogram. The angles in a parallelogram. I don't know if I've done this earlier or not, but if we have a parallelogram, if we know one of the angles, these would be the same side interior ones. The next consecutive angle would be supplementary to it. So if you know one of them, the one next to it is 180 minus that value. And then the opposite angles are congruent. So these would match here, and these would match here. So remember, the two consecutives, no matter which way you go, are going to add up to 180. So keep that in mind as we do example 3. Okay, we've got two forces acting on a point. Think of this as, say, a big crate with two ropes coming off of that crate. Force 1 is pulling with 25.6 pounds of force. Force 2 is pulling with a little bit more force, stronger person pulling the rope, 32.1 pounds of force. And then the angle between the two ropes that are pulling, 46.8 degrees. Can you find the resultant force? Now, because there's an angle between them, it's not just add these two numbers together. If they were in line with each other, then yes, you would just add them together. But because there's that angle between, they're losing a little bit of their total pounds of force that they're working with. But the key word here is resultant, which means you have to add the vectors together, which means they have to be head to tail. So let's start out with our picture. So here's our crate. Here's our point with the crate attached to it. Here's our big crate. Okay, now we got two people pulling on this thing with some ropes. One's got 25 pounds of force, one 32.1 with this angle between. So it doesn't matter what direction I make these go in. I'll just have one pull this way. I'll let this be the 32.1, pulling that way. And then the second rope, there's a little over 45-degree angle, but it's a little bit shorter vector because it has less force on it, 25.6. So they're right now, these two vectors are tail to tail. They're both pulling out with the 46.8 here. So if I want to find out how much force is actually pulling on this crate, I can add these vectors together. Remember, when you add vectors, they have to be head to tail. So you have to physically, on your paper, take one of them and slide it over, or you could slide this one up, or you could do both of them. And when you do both of them, you're creating a parallelogram. So I will slide both of them. So I will slide this one over head to tail. So the 25.6 is over here. Now they're head to tail, so pretend that one's gone. So my resultant is right here. I'm also going to slide the 32.1 up. I don't need it, but I'm going to do it. That would be head to tail, head, tail, 32.1. And now the resultant, which I'll put in this orange highlighter, is right here. That's what I'm looking for. When I add those two forces together, I get the resultant. That will tell me how many pounds is actually pulling this crate. Okay, the biggest mistake people make is they cut this 46.8 in half. It does not cut in half. If you ignore the orange line, I had a parallelogram here. If I want to get, because I have to work with either this triangle or this triangle. They're the same triangle, just rotations of each other. I'm going to subtract from 180 to get this angle in here. Then I'm going to have side, angle, side, and then I can solve for the missing side with law of cosines. So that angle in there is 180 minus the 46.8. So 180 minus 46.8. That angle in there is 133.2 degrees. So my goal is to now solve for this side of the triangle. I have a SAS situation, side, angle, side, which means I'm going to do law of cosines. So if you remember how that works, if you want to find the side, that side squared equals the two known sides squared and added, so it doesn't matter which one comes first. Then you subtract, I'm going to run out of room. I'm going to come under here, subtract, because that's all one chunk. 2 multiplied by those two side lengths, 32.1 times 25.6, timesing by the cosine of the angle between them. Oh, that was terrible. Sorry about that. 133.2. So that's all one line of stuff. And remember, this will be that side length squared, and this should all be done in one line on your calculator. So 32.1 squared plus 25.6 squared, subtract 2 times 32.1 times 25.6 times cosine of 133.2. 2,810.84. I will square root that whole answer and get R equals, and with sig figs, 53.0 pounds of force. So a little less than adding the two together because of the angle between them. So not hard to do if you remember to slide them. Okay, I think I have one example left, but we need a vocabulary. This is rolling into section 7.5, but it's just story problems. It's the same stuff, kind of like this here. So where's my pen? 7.5, day 1. The equilibriant force. Equilibriant force is the counterbalance to the resultant force. So it's just the resultant's opposite vector. So, as an example, if you had two forces acting on a point, force 1, force 2, you would get to see the equilibrium, you would add these together to see the resultant. So that means you got to slide head to tail. You can make it a parallelogram. So I'm going to slide this one up here. I'll slide this one over to the arrowhead of force 1. There's my parallelogram. So my resultant now is where the two vectors started, tail to tail, and where they finished, head to head. So there's the resultant. The equilibriant, like I said, is going to go in the complete opposite direction. So it's going to make a line 180 degrees and have about the exact same length. And I'm just going to estimate it. Here's your equilibriant. Exact same magnitude, but total opposite direction. So here we go with our last example. And I have 10 minutes of time left before this kicks me out. I think I can do it. Okay, we've got two forces act on a point. Think of it as ropes pulling a crate. Force 1, 128 pounds. Force 2, 253 pounds. The equilibriant is 321 pounds. Can you find the angle between force 1 and force 2? So we're looking for that original angle between the two ropes attached to the crate. So here's our point. Again, direction doesn't matter. I usually just start writing the first one directly to the right. So force 1, 128. The second rope is pulling on the same point, 253. I have no idea what angle, but I know it's longer than 128. And they give me the equilibriant, but remember, by being given the equilibriant as 321, I know that the resultant is also 321. So just keep an eye on the prize, though. First of all, our goal is to find this original angle between these two ropes. That's what we want to know. So we'll come back to that. So to see the resultant, remember, you have to slide these head to tail. So make the parallelogram. Slide the 128 up. Slide the 253 over. Here comes the resultant. The resultant is 321. Now I've got two triangles where I have side, side, side. I can find any angle in these two triangles. I can find this one, and this one, and this one. But remember, none of those three are actually the answer to the question. But remember, this is a parallelogram here. If I can find this angle here, I know that the angle in the other corner of the parallelogram, which is the angle I want to know, is supplementary to that. So we are going to find, I'll call that angle A, that angle, and then subtract from 180 at the end. So with side, 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 you know we're doing law of cosines. So the formula, I'll give myself a little more room this time. The cosine of A equals, and remember, you have to start with the side across from it squared. So that'll be 321 squared. Then you subtract each of the other two sides squared. Doesn't matter what order they come in because they're both subtracted. Then you divide by a -2 multiplied by the two sides that were subtracted. 28 times 253. So at this point, remember to use parentheses around the top, the numerator, and around the denominator. Then you can type that all in one line, and then inverse cosine to actually get the angle, because this will be a decimal in the end here, hopefully. So let's see how I do. 321 squared, subtract 128 squared, subtract 253 squared, parenthesis, divide, parenthesis, -2 times 128 times 253. Trying to go fast here. Going to get kicked out. A negative, so the cosine of A is a -0.34967. I'll inverse cosine that. I get 110 degrees. Oops, 110. So if this is 110, the angle between the forces will be 180 minus the 110 for about a 70-degree angle. And there it is. Okay, that ends those. I finished just under the wire. Perfect. Stop.